Problem 23. This one is tricky. This one is very tricky, actually. So the first thing you should do is think about what are my conditions? Like, what do I need to keep track of? What are the only things I have to keep track of? And the only things you really have. So firstly, I'm going to let my free variables. And by free variable, I mean stuff that like I'll give a name to, and everything else will be expressed in terms of these things, is R1, the upper radius, and R2, the lower radius. And okay. So I started by just trying to figure out how do I get the volume of the truncated cone? And in order to do that, you have to deal with some similar triangles. Yeah. So you have, this is like the central axis. This is the tangent line. This is like one of the lines of the cylinder. Here's R1, here's R2. We know this is length 2R. This is basically just, this is a cross section. And then this is H. We add an extra H up top, which is like that length. We're trying to find that. And in order to find that, we use similar triangles. So H over R1 equals H plus 2R over R2. This implies that HR2 equals HR1 plus 2RR1, which means that H equals 2RR1 over R2 minus R1. And I'm actually going to call this H1. And then if H2 is the entire thing, it equals H1 plus 2R, which equals 2R. R2 minus R1, which equals 2R2 over R2 minus R1. And this, yeah, this is a good sanity check. Height 1, height of like the cone, yeah, that's like lopped off of the smaller cone has height. The smaller cone has this height, and the larger cone has this height. And the difference in the heights is 2R. And so this actually isn't, this is enough to get us pretty close. Based on this, we can get that like 2 times the volume of the sphere is equal to the volume of the large cone, which is so we have this equation from the volume of the truncated cone is twice that of the sphere. Algebraically, that's what this is. They're the same. Yeah, volume of the cone is equal to the difference of the volume of the two, volume of the truncated cone is equal to the difference of the volume of the cones. And then we substitute H2 and H1 and then pull out the factor of 2R over, we pull out this factor. Yeah, we pull out this factor here. And then it becomes R2 cubed minus R1 cubed. But the problem is we don't really have a good condition on the value of R yet. And you actually have that R squared equals R1 times R2. So if I'm looking at it now, the way I would justify it is that if
Even
you
your
take a
screen is
cross
frozen.
section, okay.
Okay, now got it.
Yeah, there's not a lot I can do about the frozen screen, actually. It just kind of, I don't know. I never actually like fix it. It just fixes itself. Okay. So yeah, when you take a cross section, yeah, so when you take a cross section, you have this inscribed circle, which is like the kind of like the middle slice of the sphere. And then we have the diameter of the base. So like this is R2 and this is H1. And so based on this, since these are both perpendicular, you actually have that H1 plus R over R is hypotenuse over shorter and is equal to the same ratio in the it's equal to the same ratio. It's similar to the other triangle. I'm gonna bring this down more for more space. Okay. Yeah. So this is a cross section. So you have H1 plus R over R, which is this to this is going to be equal to this because the two triangles are similar. They're both right triangles. And they also both have that this angle is equal. Yeah. So that gives this ratio. And so H1 plus R times R1 is equal to square root of H1 squared plus R1 squared times R. This is quite algebraic. H1 plus R squared R1 equals H1 squared plus R1 squared times R squared. And then, yeah, you substitute in H1. So then this becomes like 2R R1 over R2 minus R1 plus R squared times R1 squared equals this whole mess. And then you multiply both sides by R2 minus R1 squared. And then you divide both sides by like R squared. So then this gives you 2R1 plus R2 minus R1 squared, R1 squared equals 4R1 squared plus yeah, and then on the right side, this is equal to 2R1 squared plus R1 times R2 minus R1 squared. And then you cancel out R1 squared. So then this becomes squared is equal to, this is quite a mess, is equal to 2 the apostrophe should go there, is equal to R2 plus R1 squared, which means that 4R2 R1 equals 4R squared. So R2 R1 equals R squared. This is actually what I went through when I was trying to do this problem. But then looking back, now that I know that R squared equals R2 times R1, there's a much nicer way to do this. And it's just that these two quadrilaterals are similar. Oh, they don't look very similar in this diagram. Oops. Sorry about that. But these quadrilaterals are similar because they both have these pairs of right angles. So the purple and the red quadrilaterals are actually similar because they both have these right angles over here. Is 100, those two pink angles add up to 180, but then these opposite angles also add up to 180. Yeah. So this is X, this is 180 minus X. This is X, this is 180 minus X, and then this is X because like the angles have to sum to 360. So that means that these two triangles have these two quadrilaterals, and then this means that R squared equals R1, R2, which is much nicer. Yeah, so the similar quadrilaterals, you can do it immediately, or you can do this algebra, which is much more motivated. Spotting these similar quadrilaterals, I was not expecting to have to do that. Yeah, we had this area condition, and now we can substitute in the thing we got of R squared equals R1 times R2. Firstly, let's do some cancellation. Okay, pi gone. Factor of R gone. Factor of 2 gone. Factor of 3 gone. And then so this leaves us with 4R squared equals R2 cubed minus R1 cubed over R2 minus R1. If you remember your difference of cubes formulas, this is actually equal to R2 squared plus R2 times R1 plus R1 squared. And we also know that 4R squared is equal to 4R1 R2. And this means that R2 squared minus 3R1 R2 plus R1 squared equals 0. And thus the ratio, like R2 over R1 squared minus 3 times R2 over R1 plus R1 equals 0. So R2 over R1 equals 3 plus or minus. Yep, and just based on that, you have that the ratio is 3 plus root 5 over 2. And that's your answer. It is quite the long haul of a problem. It's the similar quadrilaterals thing is I'd be very impressed if you could spot that in contest. Yeah. It's probably worth learning, actually. Yeah, I feel like this might appear again. This quadrilateral is similar to this quadrilateral. Like in general, if you have a trapezoid, and you have a circle inscribed in that trapezoid, yeah, you have like a circle inscribed in that trapezoid, then you'll have that you'll have that R squared equals R1 times R2. So yeah, this is a general claim, which I feel like might be useful. That might show up again. If it shows up on the AMCs, this year I'll be very amused. Yeah, and this is by similar quadrilaterals. Let's redraw it again. Purple and red are similar. Okay.